A single cloud can drop rain, snow, sleet, or hail. That's why you may have had the experience of watching it rain on one side of town while the sun shines on the other. But weather isn't produced one cloud at a time. Even an isolated thunderstorm is part of a huge weather pattern that changes with variations in wind, moisture, temperature, and air pressure. These weather patterns are composed of enormous volumes of air that carry heat and moisture from one region of the world to another. The driving force for all this movement is energy from the sun. Without it, the wind wouldn't blow and water wouldn't flow. One of the most important details about the sun's heating of Earth's surface is that it's uneven. Just as the sun's intensity varies from one time of day to another, it also varies from one region to another, with the equator absorbing far more energy than areas near the poles. Furthermore, the heat the Earth absorbs doesn't stay in one place for long. It's transmitted from Earth's surface to the surrounding air. As the air warms relative to its surroundings, it becomes less dense and begins to rise, creating an area of low air pressure. It's sort of an empty space, or at least an emptier space in the atmosphere. In response, colder, denser, high-pressure air rushes in to fill the low-pressure void, creating the movement of air we know as wind. Even though it seems like air would always mix easily, volumes of air with different temperature and humidity characteristics often don't. Scientists refer to a huge volume of air with particular characteristics as an air mass. Air masses tend to stay intact and move independently in response to winds and differences in air pressure. By themselves, they can dramatically affect the weather in areas they move into. But some of the most powerful storms arise when two air masses meet. The area where two air masses meet is called a frontal boundary, or simply a front. The interactions along these lines, which can stretch for 1,000 miles or more, can have a powerful influence on clouds and weather. For example, when a cold, dense air mass slams into a warm, humid air mass, it forces its way under the warmer air, pushing it up and causing the warm air to lift and cool. This causes the moisture in the upper air to condense into clouds and precipitate out as rain or snow, or even hail in some thunderstorms. The greater the differences in temperature, humidity, and air pressure between air masses, the more likely they are to produce severe, even deadly storms. So even if we often care most about the weather where we are, paying attention to the clouds and atmospheric conditions on a much larger scale can give us a heads up about the weather we might expect in the hours or days to come.